Alright, so this is binary how do machines work. So in the last episode, sorry if I took a bit long to make this one. I had some issues, so in the last episode we learned how logic gates work, like the NOR gate, the AND gate. Actually, I don't remember if I taught y'all the NOR gate. Well, it's just the opposite of an OR gate, so an AND gate. These two are pretty much the only things you need to learn how to do because everything else is like an application of them. We also taught us how the XOR gate works. Pretty useful. But how do machines actually use these? So you may have heard of like clock cycles and RAM and GPU, CPU. Well, I told you that in the first one, so. How binary works is okay, let's say we wanna, okay, wait, so video is talking about applications of logic. So let's say we want to add numbers. Let's say we have 1 and then 3. Well, if we put them together, that'd make 4. But how do computers do that for us? This is where logic gates. So you see, inside the CPU, there's this chip called like an ALU. For most processors, it has 32 bits. So let's just like ALU. So what the ALU does is like, let's say we have 3-bit ALU. Now this is not very traditional, but like going to have 6-bit output multiplication. I'll teach you sometime soon. So we're going to say, wait, we actually taken 2 numbers, but like, alright, so let's say we want to add 1 plus 1. And well, 1 are on in binary. Hold on, let me do it the opposite way. So this is 1 0 0 or 0 0 1, whatever you want to say. Just move that accordingly. So in this one, I don't really remember the series that much, but oh yeah, it's left. I read left to right. So alright, so we're doing addition here. We're going to do, say we want to add 1 plus 1, or 1 0 0 plus 1 0 0. Now, because binary is in base 2, so we want to add 1, and then we add 1 again. Like I told y'all, this is how you count in binary. So we've got 2. So 1 plus 1 equals 2. Yeah, that seems familiar. Because like, okay, wait, never mind. So if this one is 1, this one's on. The other one is 1, this one's on. Now this one is familiar. We can implement this with the XOR gate. Because take a look at it. So 1 plus 0 equals 1. 0 plus 1 equals 1. But when it overflows, it equals nothing. But how do we calculate the overflow? Well, when both of them are on, the other one has to be on. Just like an AND gate. The AND gate, I haven't played this in a long time, my bad guys. So this is known as a half adder. What the half adder does is that it adds 2 1-bit numbers together. But what if I want to add like another number down here? How do you make that? Well, you're going to feed it into another half adder. Because then it'll be able to take another input in. So now because these are both carries, we can just OR them up into 1. And now we're going to connect the XOR gates, which go like this. See, the reason why the XOR gate goes like this is because if you're adding 1, then it'll keep going up until 1, and it won't trigger these two. And if you want to add 1, then it keeps triggering. And if you add 2, then bada bing, bada boom. Now, let's add the carry in, or the third input. So now we have something that can add 2 numbers. So, well, 3 numbers. So, let's say we want to add 1 and 1. So, boom, we get 2. We want to add 1, 1, and 1. So, boom, we get 3. Well, 3, by the way. Alright. Now, how do we chain multiple of these adders together to make, like, ALU, the 30-bit, 32-bit math handler, sort of? Well, if we look here, we can see that this third input, it just adds 1. Like how this can add 1 to, like how this carries and adds 1. So we could, like, use this input as a carry in. So I'm just going to replace it with a node. And you can repeat this for however long you want. You just want a 4-bit adder. Well, all we do is just connect the last carry into the next carry in. Carry out, carry in. So on and so forth. Now, in my last video, you all learned how to make logic gates in Minecraft too, in the description. If you haven't learned that, it's basically just like an AND gate in Minecraft would be 3 redstone torches. This. So, lever, lever, redstone into torch, redstone into torch, or the two inputs together and then invert it, which is just a NOR. And you get an AND gate, and the redstone torch is a NOT gate. So let's try our new and improved 4-bit full adder. I'm just going to replace this input with a carry in. That's actually toggleable since we aren't going to be implementing anything anytime soon. So this is 1 plus 0 equals 0. No, 1 plus 0 equals 1. 0 plus 1 equals 1. Now let's get to the big guns. So we're going to add this, let's say. And if we do this, then it keeps going on. This design is known as the ripple carry adder. Really loud. Alright, so this is known as the ripple carry adder because each of it has to wait for the input before. So 1, 2, that's how long it takes. 2 ticks in this game at least. Let's say you want to add like that. Then it has to keep rippling. And it even lags on some inputs. You can't create like something that calculates all the logic before you, like with a whole bunch of AND gates. I mean, me personally, I just find that very annoying to make, so I don't go with that design. I mean, this is pretty neat though, ain't it? So that is how you make your 4-bit adder. In the next one, I'm going to be teaching you how to make subtraction. Goodbye.